competitive examination taken by about 1 million students every year in India. It is for entry into higher level education institutions and for jobs in Government of India. There is a February 2016 paper. It's a question on the theory of computation. Here is the problem, Gate 2016, paper 2, question 46. The question is a multiple choice question dealing with derivations in context-free grammars, CFT. Here is the problem, question 46. It says a student wrote two context-free grammars G1 and G2. We can ignore the student and say we have two context-free grammars G1 and G2. They generate a single C-like array declaration. The dimension of the array is at least 1. Here is a sample declaration. One is the type int, name of the array, and the subscripts. Each dimension in square brackets. At least one dimension must be there. These are the grammars below G1 and G2. D is the start symbol. And the terminal symbols are int, id, square brackets, open and close, and num. Let us look at grammar G1. D, L, and E are the non-terminal symbols. Grammar D2, D, L, and E are the non-terminal symbols. D is the starting symbol of grammar G1. D is the starting symbol of grammar G2. The question is, which of the grammars G1 and G2 generate the declaration as required? Array declaration with multiple subscripts, at least one dimension must be there. There are 4 choices, A, B, C, and D. Only G1, only G2, both G1 and G2, neither G1 nor G2. It's a multiple choice question. The examiner has guaranteed 3 answers are wrong and 1 answer alone is correct. So if we guess the wrong answers, what is left is the correct answer. The strategy we'll follow is try to derive the string in both the grammars. Let us start the grammar G1. We have to start with D. Here is the derivation. We start with D. Compulsory, we have int L semicolon. So L must give me this inside portion. A, 1 dimension, 2nd dimension. Because L is there, compulsorily I have name of the array and I have the starting of the 1st dimension, the square brackets. E cannot be empty. E can be at least 1 dimension, we stop here, or 1 dimension followed by open square bracket C. So 1 dimension followed open bracket is square E. To terminate the recursion here, we have to use num closing brackets. Num closing brackets. So this particular 2-dimensional array is indeed generated by D. So G1 prima facie is correct as far as 2 subscripts are concerned or 2-dimensional arrays are concerned. Let us consider grammar G2. We start the derivation with D. Int L semicolon, right hand side. L must generate this portion of the array. L compulsorily gives the name of the array and E. Name of the array and E. Now E, for example, gives me the 1 subscript or multiple subscripts follow 1 subscript. The recursion says at least 1 dimension must be there. So I have 2 dimensions. So this declaration is indeed generated by D. So grammar G2 generates the recursion properly from 2-dimensional arrays. The question is, now we have both G1 and G2 derive the string properly for 2-dimensional arrays. How about multiple dimensional arrays? We can guess the answer seems to be choice A. For both G1 and G2 seems to be correct. Only G1 is partially correct. Only G2 is partially correct. Both G1 and G2 is totally correct. The answer therefore is A. But let us see multidimensional arrays. For this we will use regular expressions. Consider this string of multiple dimensions, 1 or more dimensions for the array. At least 1 dimension must be there. This can be written as identifier, int identifier. This gives one dimension plus. This regular expression says one or more dimensions. This is indeed correct. This correctly gives me correct declarations. This is what grammar G1 does. We consider grammar G1 your ID multiple dimensions. Your ID multiple dimensions. You will also be written as this particular thing. The declaration can be written as ID open brackets num closing bracket open bracket num closing bracket open bracket 0 or more times terminated by num closing bracket num closing bracket. This is what we have. Num open bracket closing bracket 0 or more times terminated by num closing bracket. This is a regular expression for it. This correctly gives me correct declarations. So grammar G1 is correct. It gives me the proper declarations of one or more dimensions. So grammar G2 automatically gives it. So both G1 and G2 can both be expressed by same regular expression. So both generate not only two-dimensional arrays, but also multi-dimensional arrays in the required format with one or more dimensions being there. The answer is choice A. End of the presentation. Thank you for your attention.